Okay, so I can still see your chat. If you have any questions there, you can ask there. Or if you just want to speak up like we did before, we don't have a lot of people here today, so you don't have to worry about. The first problem is a quadratic, but you can see there that it has 3 terms, so it is a trinomial. So the way I work this is by using the quadratic formula. The quadratic formula doesn't give you all the answers, but it gives you a head start kind of way. Now, you can also do this by factoring if you wanted to. That's another option, but since I didn't emphasize factoring in this class, I'm going to go with quadratic. Now, the quadratic formula is on your formula sheets. I'm just going to copy it here. And I'm going to pretend this is a quadratic, even though it's not, right? It has a power of 4. It's a quartic. But if it was, A would be 1, B would be negative 18, and C would be 72. So if I keep pretending, I'm just going to plug in my values. And what I get is 12 and 6. But again, this is not a quadratic, this is a quartic. So what you got from the quadratic was not x, it was x squared. So to solve it, to get the final answer, you have to do the square root property, which is you need to put plus minus the square root of that number. Now your calculators, if you have the calculator, just put the square root of 12 and it will simplify it for you. If you don't, then you break it up into prime factors. 4 and 3, 2 and 2. So any pairs, like this pair, is going to go outside. And then the 3 didn't have a pair, so it stays inside. And I'm going to do the same thing with this one, plus minus the square root of 6. Now the 6 cannot be simplified because it doesn't have any pairs, so it stays like this. Now what you have here is 4 answers. Positive 2 square root of 3, negative 2 square root of 3, positive square root of 6, and negative square root of 6. 4 answers just like your highest power. Questions on that? The next one is just a plain quadratic. So you see the difference here. The highest power is 4. So we had to do this extra red thing after it. For this one, you would just do quadratic formula. And you don't have to do the last part I did. So the A would be 12. The B would be 1. And the C would be negative 6. And then I put it into the formula. And the answers you get are 2/3 and negative 3/4. Questions on that? I have the Pronto app open and people are asking for the link. So it's up here. I'm just going to copy and paste. So give me 1 second. I have it right there on Pronto. But okay. Let's continue. Any questions on this one? I usually put it before this, but I just didn't have the chance today. Okay, so let's do a system of equation. These are the things you recently did, and we have been doing it with substitution, so that's what I'm going to do here. I'm going to get this one because this one has an X with no number, so it's easier to work with this one. It's always easier to work with a letter that doesn't have a number next to it. So I'm going to do plus Y. I'm going to solve for X first. Once you have solved for X, then you're going to go to the other equation and you're going to substitute what you found for X. So I'm going to put 4 instead of the X. I am going to put Y plus 2 and then plus 5Y equals to 62. And now it's only one letter. So we are going to solve for Y. So it will be 4Y plus 8 plus 5Y equals to 62. I can combine the Y's. And I get 9. And then I'm going to solve for Y. So it's a linear equation. I'm just going to move the 8 to the other side. Divide by 9. And I get Y equals to 6. Now that's not the answer completely because when you're solving a system, you need both letters, X and Y. But now that I have Y, I'm just going to go in and plug it here and find my X. So X equals to 8. Now, in terms of an order pair, you always write X and then Y. So when you're writing the answer, you will write parentheses 8, 6. Questions on that? Now, this is a comprehensive exam, so that's going to have things from all the sections. I feel like this one we just covered recently, but then some things that we have covered in a long time will also pop up. Now, here we have a rational equation. One of the things that I don't think I emphasized enough before was the simplifying part. So, like on this one, if they want the y-intercept, you're just going to put an x equal to 0. And then plug it in. And whatever you get, that's your y-intercept. Now, they do want a point. When they say a point, they mean an x and a y. So your x would be 0 and your y would be whatever answer you get from the substitution. Now, if you were to put this in the calculator will give it to you automatically simplified. So it will skip this part here that I have. Your calculator will just give you 1/3, and that's fine. Any calculator will do that. If you have a TI calculator, you just change it to fraction, and it should give you that 1/3. Now, when you write it as a point, make sure that your x is 0, and then that you write the negative 1/3 like that. Now, for the x-intercepts, you're going to be working with the top of the rational equation and solve it for x. Now, in this particular one, it is a quadratic, so you would use quadratic formula. If it wasn't a quadratic, then you could just do linear. And we know it's a quadratic because of the power of 2. We know it's a quadratic because you have that right there. So when you have that, that means you use quadratic formula. Now I do have the quadratic formula in the formula sheets, and you do have it in the front of, at the beginning of this. I copied it on top of the page. Of course, if you know how to factor, you could do it by factoring, and that's fine too. So I got those two answers. And once again, here they want points. So it's an x and a y. So you would write 5/2, comma 0, and then comma for the next point, 1, comma 0. The vertical asymptotes, you get them by doing the bottom equal to 0. So I'm going to get now the bottom part and set it equal to 0. And once again, this happened to be a quadratic, but if you don't get a quadratic, then you wouldn't do quadratic formula. You would do just solve a linear equation. We're not going to give you anything bigger than that, either a linear or a quadratic. So quadratic is the hardest they get. So basically this problem is the hardest they're going to get. Now the vertical asymptotes are imaginary lines. They're not points. So here, see how on the answer it says x equals. The only thing you have to do is write the number and then comma and then the next number. These are not points. This is a line. So you don't write it as a point. Now on the horizontal asymptotes, there are videos on how to find the horizontal asymptote if you don't remember. I think there's some videos out there. Now if you can't find it, just send me a message and I'll send you the link. On how to find the horizontal asymptotes. But basically for this specific problem, now it varies depending on the problem, but for this one, the highest power of x is on both the top and the bottom. So your horizontal asymptote is just the numbers next to them. 2 divided by 2. So that would be equal to 1. Any questions on these are 4 topics from rational equations. I don't remember the specific section number, but I know it's rational functions. On the is rational functions on your schedule. So you can look there on your topic list or on your modules if you want to go back and review some of that stuff. What do you mean, the questions? For the final exam, I think so, yes. For the final exam, I think that's the order. Now this one is solving a equation with a square root. So what you have to do first is isolate the square root. You want the square root to be by itself on one side. So I'm going to move the 1 to the other side just so that the square root can be by itself. Once you have it by itself, then what you do is you're going to take the square on both sides. And what that does, it cancels the square root. So on the left, I only have 2x plus 10. Now on this side, what I end up having is 2x plus 1. So you either do FOIL or distribute it. I think here I have been doing the box. So that's what I'm going to do. But whatever method you use to multiply by binomials is fine with me. Binomials. I basically combined these two x's and that's how I got the 2x right there. Once I get rid of parentheses and do these computations, I see that there's a square there, so it's a quadratic. So what I have to do is set it equal to 0. So I'm going to move the 10 and I'm going to move the 2x. The 2x, this one's canceled, and I am left with just this. Now, on the notes that I gave you, I use quadratic formula, so you can definitely do that. But what I want to do here is to show you how to do it with the square root property. So you can also do this for this problem because you don't have a b. When b equals 0, you can do the following. Do plus 9 on both sides. And then I'm going to apply the square root property. And what that does, what that means is you do plus minus the square root of 9 equals x. So x is positive 3 and negative 3. one of the issues with this problem is when you do the square on both sides, what that does is can introduce some wrong answers. So you have to check your answers. It's not a suggestion. You have to check your answers to make sure that they work. So that's what I'm going to do next. Here, before I say these are the answers, I need to check them. And you check them with the original problem. So if I'm going to check x equals 3, I would put, instead of x, I put 3. And then minus 1. And that should be 3 if it's correct. So when I put it in my calculator, when I put this in my calculator, I do get 3 equals to 3. So I know that 3 works. And then I'm going to do the same thing with negative 3. So I'm going to do 2 times negative 3 plus 10. And then it's minus 1. And that should give me negative 3 if it's correct. But when I put this part, the left side on the calculator, I get a 1. And that's not equal to negative 3. So I know this one doesn't work. So the only answer is actually just 3. Questions on that? Yes. Yes. Any other questions? So whatever you have here, you will repeat it twice. And then you either do FOIL or distribute. This one is on exponential functions. A population of bacteria is growing according to this equation. Estimate when the population will exceed 2,798. Well, this is population, so it has to go for P. So if I substitute that, now we have to solve for t. Now, t is in the exponent. So when that happens, you have to make sure that the number with the exponents is by itself first. So I'm going to move the 1800. Now, pay attention here because this is where a lot of people make mistakes. These are being multiplied, so the opposite would be dividing. So I do have to divide by 1800. I just put it in my Casio, and I wouldn't use the decimals if I can avoid it. So if you want to keep it as a fraction like that, when I put it in my Casio, it kind of did a simplifying for me, divided it by 2, and gave me this. Now, if you are going to do decimals, just make sure that you put all of them, just to make sure you don't miss anything, and your answer comes out as it should be. Of course, I'm going to go and grade your test by hand after you turn it in. So if it marks it wrong and you just had a wrong decimal, I will give you credit. But now that the e is by itself, I am going to take ln on both sides. Now, when you do this, the ln and the e are gone, and you're left with just this. So if I want to leave t by itself, I'm going to divide by 0.07. So I get t equals whatever I get from that computation. So if I were to put it on my Casio, I get 6.30168. It doesn't say where to round, so I'm just going to round to the nearest tenth. and put 6.3. And this is another thing that it may mark it wrong if you just put 6.3, but I'm going to grade it by hand, and you should be fine. Now, for the grading of the final, I will try to get them done by Thursday for you, because I know that you're going to be anxious for your grade. So they're due Wednesday, so I will try to get everything done. Not everything, not your final grades, but at least have the final graded by Wednesday. Getting the final grades done is going to take a while, because I'm expecting some of you to still send me messages about late assignments. So that's the only reason why it may take a little longer, but everything should be, I think grades are due Monday, so it can be further, later than that. All right. Any questions on this one? This is another word problem. This is going to be a formula that is on your formula sheets. Find the amount of money in a account if you have this deposited at 3.5% interest compounded quarterly, and the money is left there for 5 years. Excuse me. The formula I'm referring to is this one. The compound interest formula. So in this formula, the P is the amount you're depositing. So this would be my P. The R is your interest, but you need to make sure it's in decimal. So I'm going to divide by 100 and get this. Now, when it says compounded quarterly, it is every 3 months. But what you want to know is how many times a year that is. So if it's every 3 months, how many times a year is that? It's 4. And the money is left there for 5 years, so that would be your T. So you substitute everything in. Now, this is one where, depending on how confident you feel, you may say, oh, I don't need to, I know, I'm just going to move on to the next one. I know how to set it up. I am good. I wouldn't take the calculator for granted, so I do recommend you type it in and make sure that you are getting the correct answer, just to make sure that you know the calculator is not playing tricks on you. And by the calculator, I mean you plugging something wrong. So that's what you should be getting. Questions on that one? Now, if at any point you want me to do any of those, if every time I mention the calculator, if at any point you want me to show you with the calculator, please just say it and I will bring it up and show you. At this point, I feel like a lot of you are already familiar with the calculator, so I really don't want to be doing it if you already know how to do it. But if any of you need help with that, I can always bring it up. This one is on on the properties of logs. Remember, there are 3 main properties that you have to remember, and that's what they want us to do here, to use those properties to expand the log. The first thing is, the way I see these is anything on top is positive, anything in the bottom is negative, and I am going to separate them. Each of them will get their own log. So this is what I do. Log x18. The x18 is on top, so it stays positive. The y is on top, so I'm going to put plus. The z is on the bottom, so when I write it, I'm going to write minus. And everybody got their own log. Now, I'm not done, because the exponent, that's another property. Any exponents need to come to the front of the log. So my final answer looks like this. Like that. Questions on that one? This one is about the inverse. It says to find the inverse and to find the domain of the inverse. Now, for the domain of the inverse, it's actually going to be the range of this one. So remember that the graph of the square root function looks like that. And what this minus 7 does, it moves it 7 down. So I'm using the properties of transformation of functions. So the original range of this function goes from, the original is from 0 to infinity. Now, on the main function, the parent function. Now, if you move it down 7, then this gets moved down 7. So actually the range is from -7 to infinity. That's going to be the domain of the next function. So that's where we're getting that from. This is in brackets, the -7. Now, when I find the range, when I find the inverse, I am going to get this function. And the first thing is to change this to a y, the f of x. Now, once you have done that, then you interchange the x's and the y's. So my x's become y's and my y's become x's. And then is where all the algebra manipulation comes in that may take a while to do. So I'm going to try to take it slow here and let me know. Just stop me if you have any questions on any of the steps. So it would be, I'm trying to solve for y. So I'm going to leave the square root by itself first. Now I need to get rid of the square root. And to do that, you do the square on both sides. What that does, it cancels the square root there. So now I have this and then minus 3y minus 2. On the previous problem, we kind of expanded this thing here with this here. But we don't have to do that here because we're not solving. We're leaving y by itself. So you don't have to complicate your life with that. We'll keep it as parentheses like that. And then we'll just make sure we leave the y by itself. So in order to do that, I do need to move the 2 and the -3. So to move the 2, I'm just going to do +2. And then to get rid of the -3, I do need to divide. So the inverse function of f is this. Now, if the function were just standalone, the domain would be -infinity to infinity. But this is not a standalone function. It's the inverse of this. So the domain is actually the range of the original one. So that's why it's not infinities. Any question on that? Because on the original parent function of the square root, it is in brackets. So basically you can have, the brackets just mean you can use the number. So if I use a number, I get 0 for the square root, and the square root of 0 is a number. So it's not undefined. That's why we use the brackets. Yes, this on the bottom that I got, you don't have to put the f inverse because it's already given to you, but you do have to write all of this. Any other questions? This one is just domain and range, and then evaluate. There's 2 different questions. This is just the domain for this one. They don't want the range, just the domain. So that domain is from left to right. So on the left, the graph starts, you see how the point is bubbled in, so you would use brackets. And then on the right, it finishes here, but we are using the domain as x's, so it finishes at 3. And since that one is an open circle, you write parentheses. Now, if it was the range, then you would do the range. You would do the y. So the range would be from -5 all the way up to 4. Now, the -5 would be open circle, or parenthesis. Now, this next one is just evaluating, but it is a piecewise function. So since it's broken up, this is your domain right here. It's broken up at 0. I'm going to create a number line and break it up at 0. And then I'm going to put my functions. Now, if I want to find -1, I need to see where it lands, on the left or on the right. So if this is a number line, -1 would be right here. So I use this one. And I get -3. Now 0 is right on the line. If that happens, you cannot use the little number line. You need to go to where I show you the domain, where I show you right here. And what you would do is see which of these has the equal on the bottom. So if we look at this one has the equal on the bottom. So that means you use that one for 0. So I would be 5 times 0 plus 4. So the answer is 4. And then the last one is 2. So I'm going to go to the number line and see where on the number line does 2 lie. Does it lie on the left or on the right? And 2 lies over here on the right. So I'm going to use this one. And that gives me 14. Questions on that? Here's one that you were recently tested on, the determinant. So the determinant of a 2 by 2, you would do multiply across. You always start on the left corner. So I'm going to multiply these two. And I get -4. And then minus the multiplication of the other two. So that would be -20. So that gives you 16. Does everybody here have the Casio calculator? More like if you don't have it, you can either speak up or write it on the chat that you do not use the Casio calculator. All right, so when it talks about the zeros, you can always use the Casio calculator to give you the answers, but if you do not have the Casio calculator, you kind of do have to do the steps. Now, it is the final exam. I don't want to pressure you to do so much work, and this one is a lot of work. So if you just have the Casio calculator, you can just do it, and you don't have to worry about showing the work for this one. Now, we do have to find P over Q, so this is your P. So what you do is numbers that give you 4 when you multiply. Well, 1 and 4, 2 and 2. So that's how I find the possibilities. Let me finish this and I can show you how to do it in the calculator. And then the Q is a number right next to the highest power here, but it's just 1. So we don't have to worry about that one because it's just 1. So these are your possible rational zeros. That just means that if an answer is a whole number or a fraction, it would be in these numbers. But if your answer has a square root in it, or if it has an imaginary, it's not there. So it doesn't have all the answers. It has any answers that are whole numbers or fractions only. What we're going to use this for is to test it out. So what you do is you start plugging in those numbers into the function until you find one that gives you 0. So let's say I try 1. So when I put 1 into the function, what do I get? I get -6. So that's not an answer, because the way it's going to be an answer is if you get 0. So when I try 4, I do get 0. So that I know that this is one of the answers. Once I get one answer that gives me 0, then I can move on to the next step. And the next step is synthetic division. You're going to put the answer outside, and you're going to get the numbers right next to these numbers. So you're going to get 1, -4, 1, -4. Now your last number here is your remainder. And for these types of problems, it should be 0 if you did everything right. Now you're going to bring the first number down, and this is anything that crosses this multiply and add it. So it's going to be 4 times 1, 4, 0. 4 times 0, 0. And then you add these and you get 1. And then 4 times 1 is 4. And see, my remainder is 0. So that I know that I did everything right. Now, when I write it in, it's always 1 power less. So if we started with x to the third up here, I'm going to start with x squared. So that's how you put the letters. It would be x squared, and this would be x, and then no letter. Since this is 0, I don't have to put it, so I end up with just x squared plus 1. Now, in the notes that I gave you, I did quadratic formula, so you can do that. But for here, I'm going to show you how to do it with the square root property. I'm just going to move the 1. And then I'm going to do the square root plus minus of -1. So what that is plus minus I. Now, when it's time to write your answers, you should have 3 because the highest power is 3. So we found the 4 and we found these 2. So my answers are 4, positive I, and negative I. Now what I'm going to do is show you with the calculator, but before I do that, any questions on these steps here? Let me grab the calculator and I can show you how to do it with the calculator. So here you have the calculator. So what you're going to do is you're going to go to mode. You're going to go to number 5, the one that says equation. And we have several here. You're going to use number 4 because that's the one with the x to the third. So I'm going to use number 4. And then you're just going to put the numbers next to the x's. So I'm going to put 1, -4, 1, and -4. And it gives me 4, which is one of the answers we got. And then it gives me I, and it gives me negative I. Any questions on that? Yeah, I did for the exams. I did want you to show me some work, but I feel like the final is already the end. And when you leave, you're probably not going to remember the steps anyway, so you may remember the calculator. So I'm hoping that there are ways not to get the imaginaries because you don't get the imaginaries, but you can get the zeros, like the real ones, from the TI calculator, I think. So if you're using the TI, maybe you can search some videos and see what you can find. on solving cubic equations or finding the zeros of cubic functions. That may be what you can search. This question is just write the equation of the circle. So it's basically plugging it in. We remember the circle is h and k and the radius is r. Now the formula for the equation of a circle looks like this. Yes, because I didn't start sharing. Sorry. I was going to share and I forgot. I was about to share. There we go, right? So here's the center. The center is h and k, and then the radius is 12. Now the formula for the equation of a circle looks like this. Now you just got to be careful with those minuses in the formula. They basically change the sign of the h and k. But if I plug it in as I see it, like the x stays and then minus from the formula and then my h, which is -1. And then y minus from the formula and then 4. And then my radius, which is 12, and then square. Now when I simplify this, two negatives are going to become a positive. And then 12 squared would be 140. Questions on that? This one is a log equation. So basically what you want to do is change it to exponents. There's several ways you can do this. And I did show you one on the notes. Basically change it to exponent or take the base. You see the 6? I'm going to do it a little different than I had it on the notes. Take the 6 on both sides and you basically just get x squared plus 9x. Now once you don't have the log, you don't need that, equals to 6 squared. And then you're solving. Now the biggest issue here is the square, because once you have a square, you kind of have to do quadratic formula, so it has to equal to 0. So then a equals 1, b equals 9, and c equals -36. And once again, I use the quadratic formula. Now I do want to see the quadratic formula set up on your work, because I do need to know that you can plug in formulas and not just the calculator. So I do expect to see this portion of work on your work, or you will not be getting credit for that. Questions on that? Now this one is playing with the properties of functions and transformations. So your starting point is the absolute value. And what it says is that it is gonna scale it horizontally by a factor of 3. And then it's gonna translate it down by 2. So if I have the function, I think they call it g, the horizontally scaled would be the opposite, because horizontal is always inside is the opposite. So that's why I put 1/3 instead of 3. And then -2 because of the down 2. And this is one that you may need to go to the sections and review different problems just to make sure, because you're not going to see a lot of, I don't think you're going to see that many variations. Maybe on the practice test if you do it twice, because all these questions are coming from the practice test. Now here we have another word problem. This is about a tourist is in a sightseeing balloon. drops his cell phone from the height of 820 feet above the ground. Ay, how sad. It must have broken, no? I dropped it from like 2 feet and that wasn't a good experience. Don't remind me. My phone is good now. I did ended up buying the new screen. Um, hold on, let me check the chat. Yes, the practice test will have the same number of questions as the final. I think it's 30. Anyways, I got sidetracked with all the nightmares about the phone dropping. Find the time t for the object to reach the ground. The height of the object is modeled by the following function. Well, if it's at the ground, the height of the object would be 0. So what we need to do is solve that. Yes, that's the one that broke at the beginning. I ended up fixing it. I ended up fixing the screen. Because when I went was no, I was gonna have to pay a lot of money. So I ended up fixing it. I think how much did they charge me? 400. Yes, 390. 400. Yeah, it was insane. But it was cheaper than buying a new one. Just because I've had it for I had it like it was fairly new. I think I bought it a year ago maybe. And they're like, you should have bought insurance, but no. I even told them there because I have Sprint on other T-Mobile. And the guys there, oh, you don't have insurance. I said, you want me to tell you the story about insurance? Because I will tell you my story about insurance. And the previous phone I had I had it like for 3 or 4 years. And I paid insurance through all those years, like 4 years or more. And then when I tried to replace the screen because the screen broke, they say, oh, it's back ordered. Oh, we don't have it because that phone is like, it's not fairly new, so we don't have it. It's going to take a while. And bring it to McAllen. I live in Rio, like an hour away. And I had a baby. I'm like, I can be going to McAllen every 2 days to leave you my phone so you can see it and then take it so you can fix it and then take it so you can pick it up. You're crazy. And I paid insurance for all those years for nothing. And now Sprint is T-Mobile, so they were like, oh no, but we're not like that. Whatever. Yeah. So because you don't replace phones so easily, the insurance, I think maybe the first year would have been good, but then after that, you may not. They don't have the screens and they don't have this and they have a whole bunch of excuses because they want you to get a new one. Anyways, sorry guys on the recording for wasting your time with this conversation. I guess all of you. I get very, very, very upset when it comes to phones. And I basically told them all that story to the guys at T-Mobile. And then when I went for the screen, because I paid by myself, I went to another with some other guys. I told them also because everybody I told them it was the same thing. You didn't buy insurance. You don't have insurance. Why would you have insurance? Oh, don't even tell me about insurance. Yeah. So, oh, it may have been easier to do it through Samsung. They would have been nicer about it, probably. I didn't think of that. See, because I did it through Sprint and no, it was, and maybe that way I would have sent it to the company and they would have fixed it easier. That's such a good idea, Derek. Well, this one, it doesn't have insurance and he still doesn't have insurance. And now he's like new, so now I pay like double for the damn phone. Sorry. All right. So we're gonna have to solve this. The height that if when the phone is on the ground, the height is 0. So, but yes, guys, I'm not saying don't buy insurance. Please don't go and say, oh, I didn't buy insurance because I missed it. But I'm just telling you my experience with insurance. And again, you can use quadratic formula here. On the notes that I gave you, you have quadratic formula. Let me get it here. I did use the quadratic formula and it's possible, but I'm going to do again, as long as I don't have a b, the b of the quadratic, I can do this and I can do the square root property. So I'm going to do that here. Makes it a little shorter, but if you feel that this is too much to remember, especially right now with the final coming up, Don't do this, just do quadratic. It's better to get it right than to spend 10 less seconds on it and get it wrong. So when I do this, I get 51.25. And then I'm just going to do plus minus the square root of that number. And I get 7.1589. Now it's plus minus, but remember that time cannot be negative, so I cannot use a -7. I'm just using the positive. It does say to round to 5 decimal places, so when I write it here, I'm going to write 7.1589 and a 1. 1, 2, 3, 4, 5. Questions on that one? Yeah, the semester went by. Now I'm thinking when you said at the beginning of the semester went by so quickly. At least for so quickly and so slow, kind of like how 2020 went for very quickly, very slow at the same time. It's almost over, guys, which reminds me, have you guys registered for the spring? Make sure you register. Most classes will be online. There will be very few on campus. Yeah, so there will be very few on campus, unfortunately, but we will have a few. And yeah, if you need any help, let me know. Whatever I can do. We do have an advisor that works with us for our division. She's really good. So if I can help you, I will always refer you with her and she will help you out as well. So let me know if you need any help with registration. I can always try to get you with someone. Sometimes with this that we can't go to campus, it feels like, well, they don't answer my email or they didn't reply to my phone call. Or sometimes we just have to do it a little bit more than usual. This one is an inequality with absolute value. This is another one that I do differently than maybe some other books. So if you already have a way of doing it and you're getting it right, no problem. Oh, my God, I'm rambling. I know. I'm going to just say one last thing and then I'll promise you we'll finish this. Even if you, next semester, if you have any issues, if you have any problems, and even though I'm not your teacher anymore, please, if there's anything I can do to help you, send me a message and I can always try to help you. So don't feel like, oh, that's it, we're not your students anymore, we can ask questions. You can. If I can, I'll help you. So don't feel like it's over. You can always contact me if you have any problems. All right, so, okay, I'm going to focus now. Sometimes I get very distracted. I'm going to focus on this now. So I do it this way. The first equation, I just do it like ignore the absolute value and just copy that inequality as it is. Now I am following the rules of inequalities, which means if I do divide by a negative, I will change the inequality. So I'm going to do -8, -8. And then divide by 7. Now I am dividing by a positive, so the inequality stays the same. Now I'm have to do another equation. In my other equations, what I do is change the signs inside the absolute value. So what that means is my 7 is going to become -7, 1. The positive 8 becomes -8. Now only inside the absolute value, so the other 7 outside stays the same. I'm going to do +8. Now I'm going to divide here to leave y by itself, but I am dividing by a negative. So this inequality is going to change. Instead of this, it's going to go that way. Now, when it comes to the interval, I do graph them first because it makes it easier to see. So you have to be careful which one is the smallest of the two. Well, the smallest of the two is negative 15 over 7. And then the negative 1 over 7. And when it comes time to graph, I'm going to look at the negative 1 over 7. And you see the arrow is pointing to the left. So that's where I'm going to shade. Now, I cannot cross the number, so I'm just shading up to there. The negative 15 over 7 is pointing to the right, so I'm going to shade to the right. So this middle portion is my answer. Now, because I don't have the equals, it would be in parentheses. So the interval would be negative 15 over 7 to negative 1 over 7. Questions on that? Tell me again. I didn't hear that. They don't go on brackets because you don't have the equal on the bottom. By that I mean if you had that little bar right there, then it would go on brackets. That one. Since it doesn't have it, it goes in parentheses. Does that make sense? I'm going to move on to this one. Now, this one is also going to be in parentheses because it doesn't have that little equal on the bottom. But this one is a quadratic. So the way you're going to do a quadratic is first you're going to have to get the answers for it, which means use quadratic formula. A equals 1, B equals 10, C equals 16. So I'm going to do the quadratic formula here. And you're going to get the two answers from the quadratic. Once you have them, you're going to set up your number line and you're going to plug them in. Again, always the smallest one first. That's important. And then you do test points. Now, the thing is, I showed you that they always alternate. So I am going to do just one of them and then I'll do the alternation. So I like 0. So I'm going to use 0. And I'm going to locate it first on the number line here. So my x equals 0 would be over here. I'm going to plug it in the inequality. So I'm going to put 0 squared plus 10 times 0 plus 16. So then I end up with 16, and this says is greater than 0. Well, that is true. So what I mean by alternate is if that's true, then this middle one must be false, and this one must be true. They always alternate. If I had gone false on this one, then this is false, true, and false. So your answers are these two different intervals. So it would be everything in parentheses, and you combine them with the U for union. Like that. Questions on that? So you do quadratic formula first, and then you do the number line with a test point and do alternate. Composition of functions, they do ask you for both f of g and g of f. Let's do f of g first. F of g means you take the g and you're going to replace the x's with that. So in the f, there's only one. Now, I did expand it on mine, but I did notice that my open math didn't. So you could basically just do 3 instead of x, put your g. And you can keep it like that, and my open math will mark it correct. Now, if you multiply it, it will also mark it correct. The second one is a little bit more tricky because you do have more x's. When you're trying to take f inside g, you're trying to take this inside the g, and there's two x's. So you do have to do it twice. I'm going to do, make sure you put parentheses, 3x minus 3 squared, and then minus 7, and then 3x minus 3, and then plus 7. And you can leave it like that. You don't have to multiply it out. Questions on that? This one is properties of quadratics. So we have a whole bunch of things going on here. I want to focus first on how to graph the quadratic, and then we'll go and answer the questions here. I feel like if you have it graphed, it's a lot easier to do the questions. So to graph it on my open math, you need two things. The first thing you need is the vertex. Now the formula for vertex, you have it on your formula sheets. H equals negative B over 2A. So my A is negative 1, my B is 10, and my C is negative 23. So to find the vertex, I'm going to do negative from the formula, and then my B, which is 10, and then 2 times negative 1. And that gives me 5. Then I'm going to plug in that number into the x's here to get k. Negative 5 squared plus 10 times 5 minus 23. And that gives me a 2. So my vertex is 5, 2. So when you go to my open math, you're going to select quadratic, which is this one. And you're going to plug in your vertex first, which is 5, 2. And then you're going to need an extra point. That extra point can be anything you want. You just gotta make sure that it's on the graph because you gotta plug it in. I like 0, but when I tried to use 0 for this problem, the answer was too big, so it wasn't working. Like you get negative 23. So I decided to use x equals 2. And when I plug it into the function, I get negative 7. So my extra point is 2, negative 7. Your extra point can be different. You can pick any point you want. Like I said, as long as it's on the graph. So 2, negative 7. It's right here. Now there is a symmetry, so just to help me do the graph here, but you only need an extra point and my open math will take care of the rest. Okay, so now that I have the graph, there's things that it will help me do, like for example, the increasing. Remember that you read the graphs from left to right. So when I look at this graph, I see that it's increasing on the first part of the graph. So it's increasing from negative infinity up to the vertex right here. Now, when you're writing these answers, you're using the x values. So up to 5. And then after that, it goes down. So it would be decreasing from 5 to infinity. This graph does have a maximum. The maximum is at the vertex. Now, when it says has a maximum of, they're talking about the y value. So it has a maximum of 2. At what x value? At 5. This graph does not have a minimum, so you would put the NE. And then we go with domain. This one, everybody should get it correct because the domain for quadratics is always, always negative infinity to positive infinity. And then the range is from the bottom to the top. So on the bottom, since I have the arrows, it would be from negative infinity up to this point right here. Now this is the range, so I use the y's. So it would be 2. This is, be careful here because you do have to put brackets on this. Questions on that one? This one has a lot of questions. All right. Now, this one is division. So with this synthetic division, when we were talking about zeros of functions, here is just asking to do the division. So when I do synthetic division, I do have a rectangle. I'm going to solve this for x. So if it's x minus 3, the answer here would be the opposite, which is 3. And then inside, you're just going to put the numbers right next to the letters. Now make sure that you have all of them. See, like I typed this here. I have 4, 3, oh, wait a minute. I'm missing x squared. So you should write zeros for anything you're missing. So now it makes sense. It has all the powers. 4, x to the 4th, x to the 3rd. I didn't have an x squared, so I put 0, and then x, and then 11. The last number here is my remainder. Now the way this works is this is times, this is plus, the first number comes directly down. So I'm going to do 3 times 1, and I'm going to put it right here. -1 plus 3, that's 2. And then I do the process again. 3 times 2. I add those up. And I do it again. 3 times 6. I add these. Do the process again until I run out of numbers. Now the question does ask for the remainder, so that the remainder is easy. It's just -1. Now it asks for the answer. What happens on this answer that I have here? It's missing the x's. So what you do is always 1 power less. You see here the 4. That means I would start with x to the 3rd. Or if you go backwards, you can start with no power on the first number. And then you start going up. X squared, x to the 3rd. So my answer would be x to the 3rd plus 2x plus 6x minus 4. Questions on synthetic division? There are many ways to do it too. This is one kind of problem with synthetic division that, especially if you just graduated high school, you may have done it differently, and that you always remember how to do synthetic division for some reason. So if you know how to do it a different way, as long as it's working, it's fine. And then the last question I have here is solving the equation. This one is the square root property applied to just this problem. So I'm going to do that. Because I have a square, you can apply the square root property. What it does is the following. You're going to get the inside of the parentheses, and that's going to equal plus minus the square root of the number on the right. Now, if you type the square root of 40 in the Casio, it will give you the simplified version of it, which you should do. But to solve for a, you do have to move the 4. Now, to simplify the 40, I am going to do the prime factors here because not everybody has the Casio to get the factors. But if you have the Casio, just plug it in and you get the simplified version here. So it would be 2 and 4 plus minus and then a 2 outside. And inside I have 2 and 5, which is 10. Now these are two answers. The thing is, on this problem, they ask you to fill in the blanks and they give you this. So they're saying, okay, what's the A? Well, the A is the number with no square roots, so which in our case would be a -4. Hey, almost forgot that negative. And then the B is a number right next to the square root. In our case, it would be a 2. And then the C is a number inside the root. So that would be a 10. So what this is testing is that you can actually simplify the radicals and things like that. Any questions on that? I will stop the recording here.